Only 30 members join. Ask your classmates to join fast because I'll be starting. Keep a message in your WhatsApp group that class has started. Everyone need to join. Yeah, everyone able to see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So anyone has any doubts in the sheet number 3 conic section? How to draw the ellipse, parabola, hyperbola?
No, sir.
Has it completed? Have you attended the previous class? Still you have doubt after attending the class?
Sir, you didn't tell us the third question, sir.
Third question, it is the same thing. Instead of dividing here, so what we do is we give the distance, CV distance as 2 parts and VF distance as 3 parts. Same thing. It is the same thing. Just it depends upon the eccentricity.
Okay.
Yeah, I will explain once again so that you will be having. So what we have to do, first we have to draw the vertical line, directrix, mark it as AB, then horizontal line, C and D, right here axis, here you have to write it as directrix. Next, depend upon the problem. Suppose in the problem, they gave that CF value, CF equal to 50. Suppose they gave CF equal to 50. You have to make it as 5 parts. 50 equal to 5 parts. You have to make 50 equal to 5 parts. You have to make, and you have to see that what is one part. One part equal to how much? We have to calculate one part equal to how much. So 50 by 5. If I do the cross multiplication, 50 by 5, so it will become 10 parts. So here, if I want to make it as hyperbola, here I'm giving 2 parts. Then VF will be 3 parts. If I want to make parabola, I have to give 2.5 parts. CV equal to 2.5 parts and VF equal to 2.5 parts. If I want to draw the ellipse, then I have to make CV as 3 parts and VF as 2 parts. So in the problem, they can ask any CF value. Example, they give the CF value as 66. If they give the value as 66, this 66, you have to make it as 5 parts. This 66 equal to 5 parts. Then you have to calculate what is the P value and you have to give the same thing. And for directly parabola, what you have to do is you have to draw the CF and bisect. Draw the arcs above and below and bisect and join it. You will get the center point. That is the V point for the parabola. Okay. So same thing, if you see eccentricity, depend upon eccentricity, you will get the different curves. VF by VC, you have to calculate. Ellipse less than 1. Now, it is not necessary to take every time 2 by 3. In the problem, they say that eccentricity is less than 1. Then you have to assume that it is ellipse. If the eccentricity equal to 1 or 2.5 by 2.5, then it is parabola. If you are making 5 parts, then 2.5 parts by 2.5 parts, numerator, denominator. If hyperbola, E is greater than 1 or 3 by 2 parts, anything you have to take depending upon the problem it is asking in the exam. Okay. So same thing. Already I have shared the video, so watch the video once so that you will be understanding. I'm not explaining. Already I gave the procedure. So what you have to do is from the vertex, after knowing the vertex, what is the VF distance? Same distance you have to give for the EV distance. EV distance is equal to VF distance, and you are marking the you are intersecting the vertical line VF EV with this radius VF. If you are cutting this vertical line, you'll get the arc here. Then you have to extend this from the C. You have to extend a line passing through the point E, and after V, vertex is the starting point of any arc for hyperbola, parabola, or ellipse. it is a starting point. So from this starting, we are making the division 1 dash to 2 dash, 3 dash, 4 dash, 5 dash. We are making the divisions and then measure the distance 1 to 1 dash. F is the focus. Focus is the center. If you want to draw the ellipse, parabola, hyperbola, focus is the center from which you will be generating the arcs. If you join all the arcs, you will be generating this one. And coming to this point, they will ask you to draw the tangent and normal. They will ask you to draw the tangent and normal. So what you have to do is you have to locate this distance. You have to measure the distance such a way that it is given in the problem. Suppose it is a 40 mm, example 40 mm. So what you have to do is you have to keep your drafter scale here and you have to measure 40 mm where the 40 mm is cutting this ellipse or any conic section where it is cutting, mark the point here. And wherever this point has to join to F, this point join to F with the drafter, and other scale of the drafter is 90 degrees, or else you can use a protractor to measure 90 degrees. And this 90 degrees line should touch the directrix line, which is AB line. It has to touch. And from this point, you have to rotate your drafter such a way that your drafter scale is passing through this T point and P point. Draw a line. And again, with the another drafter scale, you have to join this one. You'll be getting the normal. Okay. Yeah. Anyone, any doubts? You can unmute and you can ask. Anyone, any doubts? You can unmute and you can ask. Yeah. If no doubts, you can mute yourself. You are not allowed to unmute yourself. So I'm muting you. Any doubts, you can unmute and you can ask.
Parabola, I have doubts.
Yeah. So I'm going to the parabola slides. Yeah. Yeah.
For the above problem is as follows.
Yeah. The video link is mentioned here. So watch the video link once. Yeah. What is your doubt in parabola? Yeah. What is your
Tangent and
tangent? So same tangent.
normal.
You have to take 40 mm distance. Suppose this is your point. This point you have to join with the F. This point you have to join with the F. And again, you have to make a 90 degrees line. This is a 90 degrees. Suppose this is a 90 degrees example. Then
Okay.
From this point, already they have drawn the tangent here. You can draw the tangent either above the axis line or below the axis line. Anywhere you can draw. Suppose they took here as 40 mm. This 40 mm should touch the focus, which is the center. It has to touch. And this angle should be 90 degrees. This line should again touch the directrix. And you have to keep your drafter such a way that your drafter line is passing through this T point, starting in the T point and extending through this P point. Extend the line and fix your drafter and draw this normal line with the another drafter scale. You have two drafter scale. One is horizontal scale and vertical scale. When you are rotating, one will be inclined. With respect to this inclined scale, this will be 90 degrees line. You can draw either above or below. It's your wish. So I'll show you our seniors what they have drawn. So they have drawn it below. You can draw either above or below. So same problem they have drawn. So make sure that you give all the labeling such as directrix, A, B, C, axis 1 to 1 dash, 2 to 2 dash, 3 to 3 dash. And above will be P1, P2, P3, P4, P5. Below will be P1 dash, P2 dash, P3 dash, P4 dash, P5 dash. And this problem you can expect as a essay question. Directly for 10 marks, they will be asking. But they'll change the value of CF. CF values they give as 50, 45, 60, 75, 77, anything they can give upon their wish. Based on the directrix, based on CF value, you have to make it. Okay. Yeah, anyone, any doubts, you can unmute and you can ask. Explain again. So I got a message. So I'll be explaining this one. So listen carefully. I'll explain the parabola. So first I have to draw the directrix, which is AB line. I have to mark the point as AB. I'm marking the point as AB. Then I have to draw the horizontal line CD. Because this line is infinite line, so generally we don't represent D, but in some cases you can represent D. Here you have to write the value as directrix. This line is directrix and this line is axis. Then what you have to do? In the problem, they give indirectly or directly, they give the CF value. Without CF value, you can't solve the problem. They give the CF value as 60 or 50. So here I'm taking 50. So this 50, I'll mark the point as F. Because this is parabola, I'll bisect. I will take arc above and below, greater than half, above and below, greater than half, and this one. I will join this one. In the parabola, you have to do this one. Mark the point as B. Mark the point as B. Then what we have to do is draw the vertical line to locate E point. Already we have drawn A, B, C, D. Next point is E point. We have to locate the E point such a way that whatever the distance of VF, same distance is for EV. You have to draw the arc. This is the radius and V is the center. You are drawing the arc. Suppose the arc is starting intersecting at this point. Mark the point as E. Mark the point as capital letter E and extend this line. And extend this line. And this is a vertex. And from the vertex only the curve starts. Okay. And from here, what we have to do is we have to divide this V to D line. D is infinite line. We have to divide this VD line into n number of parts, which is equal or unequal. It is your wish. Equal or unequal, your wish. So I'm marking this point. I'm marking this one as first one, marking next one as 2, marking next one as 3. Unequal points I'm taking, marking next one as 4. Then what I have to do is, I know this is the inclined line. I have to extend this line such a way that it should touch the inclined line. Whatever the inclined line is there, it should touch the inclined line. So wherever it is touching, I'm marking it as 1 dash. Wherever it is touching, I'm marking it as 1 dash. So I have to extend all the 4 points. So I'm extending this one. So 2 to 2 dash. Intersecting line with 2 inclined line is 2 dash. 3 point intersecting with the inclined line 3 dash. 4th point intersecting with the inclined line 4 dash. Okay. Every time the center is focus. Focus is somewhere here. What I have to do is I have to measure 1 to 1 dash. What is the radius of 1 to 1 dash? I have to keep the center at F, and I have to extend this line below also. Bottom also I have to extend this line. Okay. So I'm extending this line to bottom also. I have to measure the distance 1 to 1 dash. 1 to 1 dash, I'm measuring the distance. F is the center. For all the L is parabola, hyperbola, F is the center. And I'm cutting my point here, above and below. This point will become as P. Example P1. On one line I'm cutting, so this will be P1. And this will be P1 dash. P1 and P1 dash. Then I'll measure 2 to 2 dash. What is the radius of 2 to 2 dash? I'll keep my keep my compass pointer at F, and I'll cut this distance above and below. Then I'll measure the 3 to 3 dash. F is the center. Then I'm cutting here. So it will be somewhere here. Then I'm measuring the 4 to 4 dash. I'm measuring. F is the center. Then I'm cutting somewhere here. And if you want to measure 5 to 5 dash, it will be above this inclined line. If it is above this inclined line, then it is not considered. So there's a limitation in a parabola and hyperbola. It crosses the inclined line, or it goes above line, goes below the axis line. So that's the reason there's a limitation. So this is my ending point. So wherever my arc is going above this inclined line, I need to stop at that point. Then I have to join all these points. This is P1, P2, this is P3, this is P4. I'm joining this one. Same thing, this is P4 dash, this is P3 dash, this is P2 dash. So I'm joining all this curve with a single stroke. Don't lift your pencil. With a single stroke, join all the points. If you lift the pencil, you will get some error. So make sure that you are not getting that error, and you have to join these things. Then you will get the required parabola. Then you have to keep your scale at this point. And suppose this is my 40 mm distance. Suppose this is my 40 mm distance. I'm marking this as my 40 mm distance. I'll mark this point as P, because already I marked P1 dash, P2, P2 dash. This point I need to mark it as P, point P. And this P I have to join with F with a normal scale or with a drafter. You can mark this, join these 2 points, P and F. And other 90 degrees point you will be joining here. This is a 90 degrees. PFT. This, wherever it is touching the directrice, mark the point as T. And PFT angle should be 90 degrees. Angle of PFT should be 90 degrees. And from this point, keep again lose your nut of your drafter and rotate your drafter such a way that it should pass, the line should pass T and P. So T and P, if you draw, it will be exactly tangent. It will pass us only through one point. Okay. And with the drafter, with one scale, you're drawing this point and fix your drafter. And again, 90 degrees, join this line. So you have to write T and T. Generally, we write T and T for the tangent. We write N and N for the normal, or N or M. You can write N for normal line, T and T for the tangent line for the curve. Okay. Yeah. Any doubts you can unmute and you can ask. If any doubts you can unmute and you can ask. And this is what your seniors have drawn. So they have represent axis, directrix, 50 mm distance, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, P1, P2, P3, P4, P5, P1 dash, P2 dash, P3 dash, P4 dash, P5 dash, T and T, which is again you have to write that it is a tangent. If you label everything, you will get 10 marks easily. You have to write it as tangent. You have to write this as normal. Okay. Yeah. Any doubts you can unmute and you can ask. You have to practice. Until unless you practice, you don't understand. If any doubts, you can message or call me so that I'll be explaining, or watch the video once. Already I've shared the video link. With respect to this video link, type in YouTube so that you will be getting the video link. Watch it once again so that while solving, watch it once, then solve, you will be understanding. If any doubts, you can message me so that I can reply you. And I want all this label correctly. Then only you'll get full 10 marks. Otherwise, marks will be reduced. Okay. Any doubts, you can unmute and you can ask. Same thing for hyperbola. He took.
Sir.
Yeah. Any doubts, you can unmute and you can ask, or else message in the WhatsApp. In the chat, you can type. Any doubt, you can type in the chat so that I can explain. Any doubts? If they give the tangent, draw a normal at a distance of 75 from directrix. Yeah, you can take even in few problems. If you see the ND but few problems, they'll give the another type. Suppose if they give us 75, then what happens is this distance is 75. Suppose this distance is 75, then you will join this and this point, and you will join this and this point, and from here you can draw the tangent. If it is 50, this is a 50 line. This is 75 line. If you take this vertical, this distance you will get joined, whatever may be the distance, whether it is 50, 40, 20, 35, whatever may be distance. Suppose this is my 75 mm line on the curve. Join this point, mark this point as P, join this point to F, and from F 90 degrees. The angle between P, F and T should be 90 degrees. Join them 90 degrees, and again rotate your drafter and join this one. You'll get a perfect tangent. And with respect to 90 degrees, again draw the normal point. It will be completed. I have regarding total number of questions in sheet 3. In sheet 3, for EI students, sheet 3 only 3 questions. For EI students, only sheet 3 is 3 questions. Yeah. Already I've shared this video. Already, this is a video link for drawing the hyperbola. So watch it and practice it. We have to take C1, C2, C3 as radius for making the arcs. Okay, once those are triple E students, once called to your sir and ask. Okay, yeah. Generally, as per the textbook, you have to measure 1 to 1 dash is the distance, F is the center, and you have to cut 1 to 1 dash line only you have to cut. Okay. Yeah. Yeah. So this is what your seniors have drawn. So it is possible to draw. Don't think
so
that
is compulsory mention normal and tangent.
Yeah, you have to mention. Then only you'll get full marks, because in the problem they'll ask. If it is not there in the problem, don't need of writing. The what are the problem I gave for the EI students? There I mentioned you have to draw the normal and tangent. So suppose I'll show you the problem. So this is a problem. In the problem I asked, also draw the normal and tangent to the curve at a point of 40 mm from the directrix. So from the directrix distance, you have to take a 40 mm distance, and then you have to draw. Similarly, it is the same problem, but in this problem, they directly told that it is parabola. In this problem, they're asking that what is the name of the curve? Name the curve. In few of the problems, they don't tell the name of the curve. They ask you to find out which is curve, whether it is a parabola, hyperbola, or ellipse. You have to find the curve and you have to write the name of the curve, such as ellipse, parabola, hyperbola. You have to write the name also. And this is normal tangent at a distance of 40 mm from the fixed straight line. The fixed straight line is the directrix. So from the directrix, it is at a distance of 40 mm, tangent normal. This can be any distance because these are the numbers. Numbers can be changed in your exam. You have to be ready for whatever may be the numbers, it is possible to draw. Okay. And if you want, you can take the screenshot of this problem. Okay, so these type of problems they'll be asking in the exam. They can ask any type of, but they'll give for 10 marks, directly 10 marks. So you can easily score 10 marks if you understand this one. Okay. Yeah, if you want, watch the video by using this YouTube link, you can solve it. Okay. And complete sheets as per the time, because we are going at a faster rate to complete the syllabus. And if you're not practicing at home, you won't understand anything. And if you won't understand anything, you have a backlog and it is unable to clear in your second year, third year, you're busy with your own works, you will be unable to clear the subject. So make sure that practice within the time. Whenever we are saying practice at that day only, write it in the observation notes. If you write it once, then you will be understanding. Okay. So write the observation notes, take the screenshot, write it at the end of the class. Okay. So I'm starting with the scales. Yeah, any doubts in the sheet 3, in the conic section, any doubts, you can unmute and you can ask. If no doubts, I'm starting the scales. Okay. So in general term, what is defined scale? In general term, what is defined scale? Have you seen the term scale on your drawing sheet? Yes or no?
Yes, sir.
Yes. Where you have seen? At the bottom, you will be having the scale. What you are writing in that scales? Why? What you are writing and why you are writing? Yeah. Any EI student?
Sir, is it new chapter?
Yeah. No. Sheet number 4.
Sir,
Conic
we have
sections.
triple also, sir.
What? Once again, repeat.
Triple also, sir.
Yeah, triple same thing. It is syllabus is same for triple and EIE. All is the same. Yeah.
Okay, sir. Thank you.
On this sheet, you have scales written. On your drawing sheet, scales has been written. Scale. What is the term you write to fill in the scale?
1:1.
1:1.
1:1. So in max term, what is meant by 1:1? In the max term, what is meant by 1:1? It is called as numbers, decimals, ratios. What is called?
Ratio.
Ratio. So what is meant by ratio? Ratio has a numerator and denominator. So here what they tell in the scale is numerator is 1 and denominator is 1. So numerator is 1, denominator is 1. So why we are considering the numerator and denominator? That's the main question. Why we need to consider the numerator and denominator question. Suppose there is a new building or a house that you want to draw it on a drawing sheet. Is it possible to draw a building or house on the drawing sheet? Yes or no? Because your drawing sheet is very small. On the drawing sheet, is it possible to draw a building or the outline of your house? Possible? Yes or no?
No.
No, not possible, because your drawing sheet is small and your building is very large, because the building is around example 10 meters or suppose 150 yards. Generally, it takes the measurement in yards, feet or inches of anything. Okay, so it is not possible to draw. It is not possible when you are taking exact dimension. Suppose it is 150 feet. Example, 150 feet is the distance, or 160 yards is the distance. That 160 yards you want to represent on drawing sheet is not possible when you are taking exact dimension. Exact 160 you want to take. You want to keep the drawing sheets, n number of 100 of drawing sheets in a single row, then you can able to draw. But if you want to draw, we have to reduce the size. Example, in your school days, you have seen the world map. So if you see the world map, this is your world map given on your drawing map. So what they do is, here, can you see this one? This is the scale. They mention the scale. They mention scale such a way that 1 mm, 1 mm represented on the world map equal to 10,000 kilometers. Suppose this 1 mm, this 1 mm I am drawn. This 1 mm equal to 10,000 kilometers. So that is the reduction, or that is the scaling they have made. So it means that numerator is scale they have reduced. So it is less than 1. So it is numerator will be less and denominator will be more. Okay. So it has been reduced to scale. Similarly, if I want to draw a world map, I have to use the scales concept to reduce the dimension, and I'm drawing. If I draw the 1 mm on the world map, it represents 10,000 kilometers, 1 mm. That's the representation of scale here. This is the one they mentioned. Okay. And if you want to draw very small objects such as any gates in a watch, if you see any mechanical watch, there's a small gear like structure here. This gear like structure will have the teeth, gear teeth. These gear teeth are very small, such as 0.2 mm, 0.1 mm, very small. If you want to draw the 0.2 mm, 0.1 mm, it will just like a point on your drawing sheet. So what we do is, we will enlarge. The numerator will be more and denominator will be less. We'll enlarge. We'll make the twice the dimension, thrice the dimension. Then we can draw. So scales is nothing but we are either reducing the size of an object. Whenever the object is larger than our drawing sheet, whenever the object is larger than our drawing sheet, we'll reduce the size of the object. Whenever the size is very smaller than the drawing sheet, then if we are unable to draw, then we will enlarge the size and we'll write. So in your previous sheets 1, 2, 3, we take the exact dimension. We have doesn't reduce the dimension. We haven't increased the dimension. We took the same dimension. That's the reason we are writing scale 1:1. Numerator is 1, denominator is 1. Whatever the assumption we are drawing on the drawing sheet length is same, and whatever the actual length, actual dimension and drawing dimension on the drawing sheet both are same, then we have to write 1:1. If we are reducing, this reducing, then denominator will be higher value. If I am enlarging, the numerator will be more. Okay. So this is the basic concept of the scale. So whatever maybe whether the object is higher than your higher dimension than your drawing sheet, or lower, very lower dimension than your drawing sheet, you are able to draw by using the scales concept. So that's the reason every drawing sheet will have the scales, because the other person should understand whether you have reduced the scales or exact dimension you have used. That other person need to know. That's the reason we will be, every drawing sheet will have the scales. Okay. Yeah. So this is the same introduction, whatever I explained. What are the objects we see in our day-to-day life has different sizes. All the objects are not in same size or same shapes. All the different objects, different sizes. So when we are representing any object on the drawing sheet, either we have to reduce the size of the object or enlarge the size of object, or else exact size. Either we are reducing the size or enlarging the size, or exact size we have to use. It has to be represented in the standard units. Suppose I'm 1 kilometer. So I'm taking the standard unit as meter. So meter, I'm taking the standard unit as meter. That meter only I have to convert in terms of meters only. That meters I cannot convert into feet. That meter I cannot convert into inches, because meter is different. Meter is a metric unit and feet and inches are the British units. So imperial units we call it as. So that's the reason we don't compare. We have to take the standard unit. If I'm taking meters, meters can be converted into centimeters. That you have to take. Okay, meters. If you are converting meters into feet, that will be, you have to use another formula. Okay. Can anyone tell me 1 meter equal to how many centimeter? Can anyone tell me 1 meter equal to how many mm? How much mm? It is 1 meter equal to how many mm?
1,000.
1,000. Is it correct? 1 meter equal to 1,000 mm. So 1 mm equal to 1 centimeter equal to how many mm?
10.
10 mm.
10
10.
mm. So,
10 mm.
yeah. So whenever you are converting, you have to take the standard units, either metric units. These are things you have to learn. I will show you few of the things how to convert. Okay. And one more thing. Suppose you take gram. Example, one of the unit to measure the weight is gram. So what is higher than the gram? Anyone know?
Kilogram.
Kilogram. So 1 gram higher than gram is kilogram. Then 1 kg. 1 kg equal to how many grams?
1,000.
1 kg equal to 1000. Okay. 1 kg equal to 1000 grams. So kg full form is kilo. Kg full form is kilo. So kilo is nothing but 1000. We take kilo as 1000. Similarly, 1 second. There is a 1 second example. Second is the unit of time. So 1 second I have taken. So this 1 second, what is the lesser than 1 second? Anyone know what is lesser?
Milliseconds.
Millisecond. Okay. So millisecond. So 1 second equal to how many milliseconds? Anyone know?
100. 60.
1 second
100.
equal to how many milliseconds is 100 milliseconds. 100 milliseconds. So milli is nothing but 100 or 1000. Check 1 second. So milli. So suppose if I measure anything in meters, 1 meters equal to millimeter. I have asked 1 meter equal to how many millimeters I have asked. Milli is nothing but 10 to the power of 3. 10 to the power of minus 3. 1 by 1000. If I take 1 by 1000, then it is milli I call. 1 meter, I have to convert into millimeter. Milli is nothing but 10 to the power of minus 3. So like that, you have few abbreviations such as 10 to the power of 1, 10 to the power of 2, 10 to the power of 3 is the highest value. Similarly, 10 to the power of minus 1, 10 to the power of minus 2, 10 to the power of minus 3 is the lesser value. So I'll show you the table so that you can, all the standard units are represented as. If you see, this is my standard 0, 1. If I want to make 10 to the power of 1, it is called as deca. So similarly, if you want to consider as 10 years, we call decade. Decade is nothing but 10 to the power of 1. So for 1 year, I'm multiplying it to 10. Then it will become a decade. Similarly, if I want to find out 10 square, 10 to the power of 2, it is called as hecto. We call it as hecto. Similarly, 10 to the power of 3, we call it as kilo. Similarly, if I want to make 10 to the power of minus 1, it is deci. Similarly, 10 to the power of minus 2 is centi. 10 to the power of minus 3 is milli. It is represented by tenth, 1 by 10th, 1 by 100th, 1 by 1000. So if you take it in terms of decimal, 10 to the power of 0 is 1. 10 to the power of 1 is 10. 10 to the power of 10 square is 100. 10 cube is 1000. This 1000 directly we called as, instead of saying every time 1000, we call it as kilo. Instead of saying every time 100, we call it as hecto. Instead of saying every time 10, we call it as deca. Similarly, whenever we want to represent 1 by 10th or 10 to the power of minus 1, yeah, everyone mute yourself. I don't want any disturbance. Any doubts? I will ask you any doubts. At that time, you can unmute. So similarly, anytime, similarly, if I want to make 1 by 10th, then it is called as deca. 0.1 is deca, and 0.01 is centi, 0.001 is milli, is nothing but 1 by 1000. 1 by 1000. Suppose meter is the standard distance we take. So this is called decameter, hectometer, kilometer, decimeter, centimeter, millimeter. Suppose here we take it as gram. Decagram, hectogram, kilogram, decigram, centigram, milligram. Suppose we take the standard unit as second. Decasecond, hectosecond, kilosecond, decisecond, centisecond, millisecond. We call in these terms. Okay. And everything has a shortcut symbols. So kilo should be represented as by the letter K. Hecto should be represented by the letter H. Deca should be represented by letter DA. Deci, because DD are common, so deci will be represented as the letter D. Centi is represented with the letter C. All these are small letters. Don't consider this as capital letters. It is a small letters. Milli we consider as M. So suppose if I take standard unit as meter, this will become a DM, decimeter. So if I write anywhere DM, it is called decimeter. Anywhere if I write CM, small letter CM, it is called centimeter. Wherever I write small letter mm, it is called as millimeter. Similarly, wherever I write DAM, all small letters, DAM if I write, it is called decameter. Wherever small, if I write HM, H small letter, M small letter, it is called hecto. Wherever I write KM, it is nothing but kilometer. Okay, so these are the standard things you have to understand before starting the scales. Okay, any doubts you can unmute and you can ask, because I'm changing the slide. Any doubts you can unmute and you can ask, or else type in the chat. I hope no doubts. Okay, so I'm going to the next slide. Yeah, so metric units, there are two types of units. One is metric units and imperial units. Metric units, few of the countries will use metric units, few of the countries will use imperial units. So I gave the relationship. What is the relationship between meters, decimeter, centimeter, millimeter, and what is the relation between meter, decameter, hectometer, kilometers in terms of millimeters? Suppose I'm taking millimeters as the standard one. Suppose I'm taking millimeter as standard 1, then centimeter will become as 10 into 1, 10 mm, and 1 mm equal to 10 square. 1 mm equal, 1 decimeter equal to 10 square mm, and 1 decimeter equal to 10 centimeters. Similarly, for meters, 1 meter equal to 10 to the power of 3 mm, and 1 meter equal to 10 square centimeter. 1 meter equal to 10 dm. Dm is nothing but decimeters. Every time you have to write in small letters, not in capital letters. Okay. Next, decameter. 1 decameter equal to 10 to the power of 4 mm, 10 to the power of 3 centimeters, 10 to the power of 2 dm, and 10 meters. 1 hectometer equal to 10 to the power of 5 mm, 10 to the power of 4 cm, 10 cube dm, 10 square m, and 10 dam, decameters. 1 kilometer equal to 10 to the power of 6 mm, 10 to the power of 5 centimeters, 10 to the power of 4 dm, 10 to the power of 3 m, 10 square dam, and 10 hm. So these are the things you have to understand before starting the problem. In the problem, they say that represent 10 kilometers and hectometers. So you have to know 1 kilometer equal to how many mm. 1 kilometer equal to 10 to the power of 6 mm, and 1 hectometer equal to 10 to the power of 5 mm. These are the values you have to know before starting the problem. If you don't understand this, you don't understand the problem. Okay. Any doubts you can unmute and you can ask. Any doubts you can unmute and you can ask. Okay. So I hope no doubts. I hope no doubts. So I'm going to next. So apart from metric units, in the metric units, generally Americans use metric units and Indians follow Americans. So in India also we use metric units, but there are few European countries which doesn't follow metric units. They follow their own units such as inches, foot, yard, chain, furlong, mile. Okay. So example, inches. If it is very small, they don't consider as mm. In the European countries, they consider as inches. Suppose if you want to measure the height, you don't tell your height in terms of centimeters or millimeters. Generally, you tell your height in terms of feet and inches. Suppose 5 feet 9 inches, 6 feet 2 inches. You tell the height in terms of foot, in terms of imperial units. Similarly, if you want to measure the distance of a cricket pitch, it will measure in terms of yards. Wherever you want to keep the distance of the cricket pitch between the two wickets on both the ends, it will measure in terms of yards only, not in terms of centimeters or millimeters, because cricket was invented by the British. In the European countries, they used to pay. They follow only imperial units. They doesn't follow metric units. So if you want to explain your drawings to the other European countries, you have to follow imperial units. You have to use inches, foot, yard, chain, furlong, mile. So there is a relationship 1 inch. Generally, if you want to represent the units of the inch, I write IN in small letters, or else 2 hyphens I can write in inch. If I want to represent foot, FT I can write, or 1 hyphen I can keep, and 1 foot equal to 12 inches. So if I want to measure 1 foot, 1 foot equal to 12 inches. So you can't say that I am 5 feet and 12 inches. You can't say. You directly say that 6 feet in height. You can't say that 4 feet 12 inches. You will say that 5 feet, because 1 foot equal to 12 inches. Similarly, it is important. I'm going slow because it will be asked in the exam. They'll give the 1 yard equal to how many foot? 1 yard equal to 3 foot. Like that, you have to know 1 yard equal to 36 inches. Next, they'll ask the chain. Any problem they can ask in the exam. Okay. Next, chain. 1 chain equal to 22 yards. 1 furlong equal to 220 yards. 660 feet. You can because the calculators are allowed in your exam, so that you can calculate on your own. No need of by having this one. Just know that 1 meter equal to 10 to 1 kilometer equal to 10 to power of 6 mm, and all these things you have to know. These you can calculate if you know the what is the relationship between millimeter, centimeter, centimeter, decimeter, decimeter, meter, meter and decameter, decameter and hectometer, hectometer and kilometer. If you know the relationship, then you can calculate. Calcs are allowed. In the calcs you can calculate. Okay, 1 foot equal to 12 inches, 1 yard equal to 3 feet, 1 chain equal to 22 yards. Like this you have to calculate. So generally the problems don't go beyond the yards. So till yards you have to remember. Minimum you have to remember till yards. Okay. Yeah.
Don't worry, I will give you the contact number. Who's that?
Okay.
Don't worry, I will give. And one more thing, sir. Wait
Yeah.
for 2 minutes. I just want to clear one doubt.
Yeah.
Someone asked, rule number 39 asked regarding parabola construction. I think so. 39, right? So whatever I said is correct. We can follow 2 procedures. We can use this procedure as well as we can use procedure set by Cycran sir. So the procedure set by Cycran sir is followed in ND Bud book, where I said the procedure, this procedure followed by Basant Agarwal textbook. So there is no wrong in that procedure. Both are correct. You can follow anyone. You can follow Cycran sir procedure or my procedure, nothing will happen. That is correct only. Okay. 39 regarding construction of parabola. Okay, still you have any doubts regarding construction of that is not correct. That is correct only, that is not wrong. So and one more thing, you need my remember, right? So
Yeah.
so
One more person. Yeah, sir, you can type it in, so they can see.
You can cross check 9949363637. Otherwise, you do one thing. All of you just create one group for engineering drawing for Triple E, and if you have any doubts, you can post your doubts in that group. Then I can give you the solutions. Okay, sir. Sai, sir.
Okay, sir. I'm continuing, sir. So one person asks, what is FT or hyphen? So generally what we do is, whenever we are measuring the units, I can write 3 and this one. It means that it is 3 feet. It means that it is 3 feet. Whenever I write 3 feet and 7 inches, then whenever I want to represent 3 feet 7 inches, I'll write this 3 feet and 7 inches. So this is the symbols we follow for the, yeah, this is the symbols we follow for the writing, represent the value. Suppose it is how we write 3 centimeters and 7 mm. Similarly, instead of writing the letters, they don't use letters, they use these symbols. So I'm writing it as suppose 5 feet and 9 inches. So you have to represent like this. This value represent 5 feet and 9 inches. Okay, instead of writing centimeters mm, they don't use the letters. Instead of letters, they use symbols, 5 feet and 9 inches. Okay. So either you can write FT for representing feet, or else you can use this symbol, so that anything is correct. Or is nothing but either you can use this symbol or this letters or this symbol, anything you can use. Okay. And metric units, these are the metric units and these are the imperial units. In all the European countries, they'll use only imperial units. They don't use metric units. Okay. All the countries related to America, they will use metric units. Okay. And there's one more conversion. There's a conversion of imperial units to metric units and metric units to imperial units. Okay. And if I want to convert 1 inch into centimeters, 1 inch equal to 2.54 centimeters. If you in few of the scales also this is mentioned. Okay, 1 inch equal to 2.54 centimeters. So similarly, if you want to calculate foot, 2.54 into 12, if you make, you will get 1 foot. What is the value you will get? If you want to
So
measure
1 feet equal to how many inches, sir?
1 foot equal to 12 inches. Feet is a multiple. If you is more than 1, then you call feet. If it is only single one, we call it as foot. Okay. 1 foot equal to 12 inches. If I want to convert foot, so 1 foot equal to 12 inches. So 12 into 2.54. If I make, I'll get this value. So you can use a calci and you can calculate. If you forget anything, you can use a calci and you can make 1 yard. 1 yard equal to 3 feet. So 3 into 30.48. If I make, then I'll get 91.444 centimeters, or in terms of meters. If I want to convert 1 yard into meters, it is 0.914 meters. And 1 mile. So generally in the European countries, they doesn't consider kilometers as the distance. They say that it is 10 miles, 12 miles. They call it as in terms of miles. And in the European countries, they doesn't take weight in terms of kgs. They take in terms of pounds. So similarly, there will be some conversion. So similarly, mile, 1 mile equal to 1609.344 meters. So this meters, because 1 mile equal to 760 yards. So you have to multiply 760 into 0.914, then you will get this value. In terms of kilometers, if you take in our India, if it is 1.609344 kilometers, then they, in the European countries, they call it as 1 mile. They measure the distance in terms of miles, 10 miles, 2 miles, 2.5 miles. They measure in the terms of miles. So you need to know the conversion. In the exam, they can ask either imperial units or metric units. If they ask in imperial units, because in India we use metric units, so you have to convert that imperial unit into metric units. Okay. Yeah. Next, same thing, reverse, metric units into imperial units. So 1 mm equal to 0.03937 inches, and 1 centimeter equal to 0.3937 inches. 1 meter equal to same thing, whatever mentioned, same thing. 1 kilometer equals 0.62137 miles. So in the European countries, if you see that it is 1 mile, then in Indian terms, it is 0. This is a value. If you 1 kilometers, this is the miles, in terms of miles you are making. Any doubts, you can unmute and you can ask. You can take this screenshot so that it will be helpful for you. Okay. When I'm solving the problem, that I will solve. At that time, I don't explain what is the conversion. You have to make the conversion. You have to understand all these tables. Okay. I'm going to next slide. So next slide will be, so now you have seen that standard length is a one-dimensional element. Length is a one-dimensional element. What is a two-dimensional element? Can anyone know what is meant by two-dimensional element? Anyone?
Area.
Area. So if I take area, it will become length and width. It will become area. So if I want to calculate area, can anyone tell me what is the area of a square?
Side square.
S square. So suppose this is my L distance. This is my same distance. If I'm taking L, then L into L, area will be L square. Okay. Suppose this is a rectangle, L into W. So what will be the area of rectangle? Anyone? What is the area of rectangle? LB, we call as length into breadth. So here, if it is a square, it will become L square. If it is this area, if it is a rectangle, it will become L into length into width or breadth. What is the third dimensional? 3D. 1D is the length, 2D is area. What is the 3D?
Volume.
Volume. So in the volume, what happens is we have length and width. For this length and width, we are giving thickness. We are giving thickness at certain distance. We are giving the thickness. Okay. So this will be your length. This is your width, L, W, and H. This is your L. This is your W. And this is whatever may be this distance. This distance we call it as H. L, W, H. So if I want to calculate the volume, what I do is if it is a square, cube, if I want to calculate the volume of a cube, it is S cube. S cube. If it is any other dimension, then length into width into height. Then I'll get the area. Then I'll get the volume. For the length, directly I'll measure the L. For the area, I'll measure length into width. For any volume, length into width into height. If I make, then I'll get the area. So similarly, the same concepts, what are the concepts you learned in metric units and imperial units, this same concept will be applying for the areas and the volumes that you will be seeing in the next slide. So if you see the standard area, if you want to measure any of your house, you measure at it is in a square kilometers or hectare. You call, if you have any paddy fields or any field, they'll measure in terms of hectares. 1 hectare equal to 10,000 square meters. So you have to know. So here what happens is, I'll explain. Suppose you already know that 1 centimeter equal to 10 mm. You already know that 1 centimeter equal 10 mm. So here what happens is, this side is 1 centimeter, this side is 1 centimeter. So this is 1 centimeter and this 1 centimeter. So what happens is, so 1 centimeter into 1 centimeter. So we called as 1 square centimeters, 1 cm square we called, because we have multiplied 1 centimeter into 1 centimeter, 1 into 1 will be 1, and cm into cm, it will become cm square. And here also we multiply 10 mm. Already we know that 1 centimeter equal 10 mm. 10 mm into 10 mm. 10 into 10, it will become as 100. And mm into mm. Yeah.
Who is roll number 258 and 1029? Just mute yourself.
Sir, you can mute yourself. Sir, in the options, you are logging from mobile.
From 2 devices.
Okay.
So,
okay, I will make you as co-host so that another device also make co-host. You can click on mute. Yeah. So whenever you want to convert 1 centimeter into mm, we know that 1 centimeter equal to 10 mm. But for the area, what we do is 1 centimeter into 1 centimeter. So 1 into 1 centimeter into centimeter. It will become centimeter square. Similarly, if I want to, this is the 1 centimeter equal 10 mm. 10 mm into 10 mm. 10 into 10, 100. Mm into mm square. So like this, you have to calculate. 1 square centimeter equal to 100 square millimeters. Similarly, 1 square meter equal to 1000 into 1000. It may 1 meter equal to 100 centimeters. So 100 into 100, 10,000 square centimeters. Like this, you have to calculate. Okay. Similarly, for foot, 1 square foot equal to 12 into 12, because we know that 1 foot equal to 12 inches. 1 square foot equal to 12 into 12. It is 144 square inches. We know that 1 yard equal to 3 feet. 1 yard equal to 9 square feet. 1 square yard equal to 9 square feet. So like this, you have to calculate. So it is easy. You can calculate. Because calcs are allowed in your exam. If any problem asked on the areas, you can calculate on your own, because in the problem they can ask on the length, on the area, on the volume. Okay. Same concept is kept for the volume also. Yeah. Whatever I'm 108 8 roll number from EIE. So it is a little bit practice once, it will be easy. And whatever I'm explaining, it is not guaranteed that everything will be asked in the exam. Few topics will be asked, few topics you have to understand on your own. Okay. Similarly, for the volume, 1 cubic centimeter, because we know that 1 cm equal to 10 mm. So 1 cube cm cube equal to 10 cube. 10 cube is nothing but 1000. So it will be 1000 mm square. This whatever I'm saying today in this till now, it is a basic common things wherever you observe. If you want to buy any area, land, if you want to buy any land, they measure in terms of square foot. They say that 130 square foot, 230 square foot, or they measure in terms of yards, or they measure in terms of hectares. If you want to buy any fields, agriculture lands, they'll measure in terms of hectares. So these are common things. Common things we will be using in day-to-day life. If you are very familiar to buying and selling the lands and other things, it will be equal. And you already know 1 mm equal to centimeters. After centimeters, what are the things are there you have to learn. Okay. So you know already millimeter above centimeter. After centimeter, it comes decimeter. After decimeter, it comes meters. After meters, it comes decameter. After decameter, it comes hectometer. After hectometer, it comes kilometers. So like this, you have to remember these things. These things are compulsory. You have to remember what are the different stages of converting millimeter into kilometer. These things compulsory you have to know. These things either you by heart or learn, understand anything. These things compulsory you have to learn. How the millimeters, what are the steps to become from millimeter to kilometer. Okay. Yeah. So these are the topics, few topics. How to measure the length to 1-dimensional, 2-dimensional, and 3-dimensional. Okay. So I'll start the scales topic. Actual scales topics start from now. Okay. So already I told that scale is 1:1. You write 1:1. So this 1:1 is the what are the drawing you are drawing on the drawing sheet by actual dimension. Suppose your building is 10 meters. Example, your building is 10 meters and you are drawing, then you are reducing the size to suppose 10. So what will happen is you are reducing the size and your actual size is 10 meters and you are reducing the size. So based on that, numerator and denominator by scale ratio you will be making it. So whenever you are drawing exact size, full size scale, it is 1:1. Numerator is x, denominator is y. Numerator equal to denominator. Full size scale. Reducing scale, denominator is greater than, y is greater than x. That is reducing scale. Okay. And whenever enlarging scale, whenever we are making the object more, we are giving double dimension, triple dimension, numerator will be more compared to the denominator. Numerator will be more compared to the denominator. Okay. These are the different things we have to follow. Whenever I say 1:1, exact dimension I'm drawing. Whenever the denominator is more, I'm reducing this size. Whenever the numerator is more, I'm enlarging the size. And there are few types of scales. In your syllabus, there are total 3 types of scales. One is plane scale, diagonal scale, and Vernier scale. Plane scale, use the plane symbol. Plane scale, they directly take the plane. Normal scale they take. Diagonal scale, they take the diagonally. They take the diagonal principle and they generate, because this is a rectangle. If you take, they use the diagonal principle. They use the diagonal principle for this rectangle and they will start. Okay, that's the reason it is diagonal scale. And next is a Vernier scale. This Vernier scale is generated by Paul Vernier, a mathematician. Generated this Vernier scale. Based on this Vernier scale, Vernier calipers has been generated. Okay, so it uses the Vernier calipers principle in order to generate the Vernier scale. And next are the few scales, comparative scales and scale of chords. It is out of syllabus, so we don't discuss these two scales. These two scales you can find it in your textbook, but in the only for mechanical and civil students they discuss this type of scales. For all the other branches they don't discuss 4 and 5 scales. Okay. Yeah, so I'm going to next slide. So there are few definitions you need to learn. First is the scale factor. First definition is the scale factor. First definition is the scale factor. I will take more 5 minutes so that we'll completing this one. First one is the scale factor. It is a ratio of length of the object represented on the drawing sheet by actual length of the object represented. So what happens is ratio of length of the object. So on the drawing sheet, I'm drawing 1 centimeter. On the drawing sheet, I'm drawing 1 centimeter, but actually it is 10 centimeter. Example. But actual size is 10 centimeters, but on the drawing sheet, I'm writing as, I'm converting 10 centimeter to 1 centimeter. So what happens? 1/10 centimeter. So this is my scale factor. We call it as SF. Okay. So similarly, for the length, drawing length by actual length, we take L and L. Next, if the problem they asked in terms of area, drawing area by actual area, L square by L square. Next, if it is in terms of volume, drawing volume by actual volume, L cube, because it is a square, we are representing in terms of length. So if already it is L square, I want to make it as length. Then what I have to do is I have to square root of L square. If I make this square root of L square, then I'll get the L value. Similarly, for the volume, I have L cube. So I have to take it as cube root in order to find the value of L. Whatever may be the area or volume, I have to convert in terms of L. I have to convert in terms of L. So here I'll take cube root of L. It will become as L. Okay. So this is a scale factor or RF. Without this RF, you can't solve the problem. Okay. Actual length. What is the drawing length you are making on drawing sheet by actual length? Suppose the building length is suppose 10 meters. 10 meters. And here we are assuming that this 10 meters I'm writing in terms of 5 mm. 5 mm. So in this problem, this 5 mm is if I draw a 5 mm line, it will become 10 meters of the dimension. Actual size is 10 meters of a building. In the numerator, I'm writing the what is the actual dimension I'm taking here. Yeah, 43 roll number. I'll be sending the sheet 4 notes in our WhatsApp group or in the Google Classroom. I'll share these notes so that you can take. And while calculating RF, numerator and denominator should have same unit. Suppose the numerator is in mm, the denominator should also be in mm because it is a ratio. In the ratio, numerator denominator value should be cancelled. Okay. Suppose the numerator is in centimeters, denominator should also be in centimeters. Suppose the numerator is in terms of inches. Numerator is in terms of inches, denominator should also be in terms of inches. Okay. You have to use the same units, mm, centimeter, centimeter, same thing. That is the main thing you have to calculate. Suppose the numerator you are taking centimeters and denominator you are taking mm, it is the wrong value. Compulsory you have to take the same value. Okay. Next you have to find out LOS. LOS is nothing but length of scale. So length of scale is nothing but, suppose I want to represent 10 meters. This 10 meters, how much I am drawing here, they have to calculate the length of scale. This length of scale you can calculate only by RF value. Only by RF value you have to calculate. Length of scale equal to RF. RF is nothing but the representative factor or scale factor multiplied by the distance to be represented. Suppose I have to represent the distance as 100 is the distance I have to take. Then RF comes as suppose 1 by 10. So this 1 by 10 into 100, I have to make, it will become as 10. So it will become as 10 centimeters. Okay. Suppose this value is 100 centimeters. Maximum distance is 100 centimeters. So I want to, I'm taking my representative factor is 1 by 10. So 10 cancel, it will become 10 centimeter. Okay. Then I have to draw the 10 centimeter line. This 10 centimeter line will represent 100 centimeters based on the RF value that you have to solve here. Okay. So before solving the problem, you have to know this, what is the RF value, what is the length of scale, you have to calculate. And note, LOS is usually calculated in terms of centimeters or millimeters. So don't take other values, only take centimeters or millimeters, preferable centimeter. In this scales problem, you will be taking LOS value in terms of centimeters. And in some cases, they don't represent maximum distance. In some problems, they don't give the maximum distance. Then assume the round off value. You can round off to higher value, higher whole number you can make by using this one. Okay. And generally LOS will be in between 10 centimeter to 25 centimeters. If any LOS is crossing more than 25 centimeters, it means that you have done somewhere mistake. If it is below 10 is also you have done somewhere mistake. Generally the LOS will be between 10 to 25 centimeters because your sheet has certain limitations. So that's the reason LOS will not cross greater than 25 centimeters. Okay. Yeah, I will. Okay. So wait for two minutes. I'll be completing this one. Plane scale. We have to find the LOS value and we have to divide the main scale into number of parts. I have to mention into two subsequent units. Suppose unit and fraction. Suppose example, 2 are meters and decimeters are two consecutive units. Consecutive nothing but similar units. If this is a millimeter, centimeter, all the other meters. If you see the meter and decimeter, both are at same. After meters, it will be decimeters. After kilometer, it will be hectometer. After feet, it will be inches. So consecutive units, you can't take centimeter and kilometer, because in centimeter and kilometer, you have one more units. So you can't take different units. Continuous units you have to take. Subsequent unit you have to take in the plane scale. Okay. Yeah. So next thing, so this is a normal scale of 15 centimeter. Normal scale is different from plane scale. How the normal scale is different from plane scale, we'll be learning in the next class. So I'm closing the end. And everyone raise your hands, we'll be taking the attendance. Everyone raise your hands, we'll be taking the attendance. Anyone not raising the hands will be marked as absent. Anyone not raising the hands will be marked as absent. Only 35, 36, 38. Everyone need to raise their hands. Yeah, only few members. Only 66 raised. Others are not listening the class. If you're not listening the class, it is very not a easy subject. If you understand, it is easy. If you're not understanding, it is really difficult subject. It is difficult to pass.
Sir, EIA also, no, sir?
Yeah, both. EIA, triple E, because this is a combined class. EIA and triple E, both of you need to raise your hands. Okay. Only 75 members raised. Yeah, we have a protocol saying that anyone not raising hands, we can mark them as directly as absent. Okay. So make sure that compulsory you need to raise your hands. Okay. So in the plane scale, compulsory you have to take consecutive units such as centimeter, meter, centimeter and millimeter, meter and decimeter, kilometer, hectometer, feet, inches, or millimeter or 1/10th millimeter you have to take. Okay. Yeah. So only 79. Only these 79 members will only get the attendance. I'm lowering all the hands. I'm lowering all the hands.
Sir.
Yeah, I'm lowering all the hands. Yeah, attendance completed. Any doubts you can ask or else you can leave. Any doubts you can ask or else you can leave the meeting.
So rule number 21 present.
Yeah. Ask to Haribabu sir.
So rule number 21 means you are from EIA or triple E, how you know?
A.
EIA. Okay, fine. You're present. Why you are getting the doubt? If you are in class?
Yeah, raise the hands within the time. I'm lowering all the hands. Lowering all the hands. Attendance completed. Lowering all the hands. Now don't raise your hands. Yeah. Any doubts you can unmute and you can ask, or else you can leave the meeting. Any doubts you can unmute and you can ask, or else leave the meeting. Attendance completed. Don't raise your hands. Yeah. Those are no doubts. You can leave the meeting. I'll wait for 1 or 2 minutes. If any doubts, I'll clarify. No doubts, you can leave the meeting.
Sir, 49 present.
249.
Sir, EIA
Yes, sir, 249 present.
rule number 8 present, sir.
Rule number
4. EIE 4.
Okay.
Yeah.
Triple E 249, sir. Triple E
Okay.
249.
Rule number 8, sir.
Present, Amma. Present.
Okay. Any doubts, you can unmute and you can ask.
Thank you, sir.
Okay. I hope no doubts from others. Yeah, I will share it in the EI group. I will share it in EI group. If you have any friends or any triple students have friends with EIE, they can collect from EIE students. Okay. Yeah. Okay. I'm ending the session. Sir, I'm ending the session, sir.
Yes, sir. Okay, fine.